Okay, I'm going to show you how we can work out the focal length and the focal point for a lens. So I'm going to start with drawing the principal axis and just our line at 90 degrees to denote where our lens is going to go. And we're using 3 rays, or the 3 slits in our light box. And the middle ray is running straight through the principal axis. I've got a convex lens here, and we're going to whack this in as just like this. We just need to move it around a little bit so that the light converges right on the principal axis. And as you can see, this spot here, where the light converges, that is the focal point, and that's called F. So the focal length is the distance between the lens, the center of the lens, and the focal point. So I can go ahead and measure what that is, because I want to, so that's 76 millimeters, because I want to do the same thing on the other side, and go ahead and mark that. Okay, so that's F on this side as well. Right, now what I want to show you is how we can create a ray diagram, not theoretically but practically, using our light box. So this time we're going to change it around and have a single slit of light, and we're going to have our lens back. Now the first ray, I've got to actually put my object in as well, don't I? So we're going to go for an object. I'm going to almost back as far as I can so you can still see it. Maybe about 2 centimeters tall. Okay, so our object is like our arrow. Now, so our first ray goes through the top of our object, parallel, importantly it goes parallel with our principal axis, goes through our lens, and it refracts through F, just like that. So again, we know that this happens. Well, we can draw it theoretically, but it's really good to be able to see it in real life. And then I can just draw that in, or I can mark some dots first. And that's that first ray. I could draw the whole thing, but I don't really need to, because what I'm really interested in is where the image is going to form. The next ray runs from the top of our object through the middle of our lens, and it comes out here. So what we're really interested in is the point where these light rays converge and come together. So that's where we can see our object. And so this one is actually enlarged because our object was 1.5 centimeters, and now our image is 2 centimeters. So it's enlarged, and it's real because our light rays have actually converged to that point. So there you go. We could do our third ray as well, which would go through the F on the object side, through the lens, and if we get that right, that should line up to the same spot as well, just like that. There you go. So it's not just theoretical, we can actually demonstrate it with light that convex lenses do actually refract light and form an image.